All right, what's up, gang? If I can call you that. Today is a episode of the Slate Robotics podcast. Thanks for joining us today. My name's Zach. I'm the CEO of Slate Robotics. We build human-sized robots for hackers, and excited to have you. Sorry I didn't have a video last week. Things are busy, but we're back on it, man. We're not gonna. You can miss 1 week. You can't miss 2 weeks. That's the rule. And yeah, I'm excited about today. So today we're not going to go through the typical Reddit posts like I've done in the past. I've just got a few topics. I really want to keep these videos short. I know every video I start with, I want this video to be brief because I don't have all day to make these videos, but I'm just the kind of guy, if I'm into something interesting, I just can't put it down. And I do enjoy making these videos. So we're going to try to keep it brief, but it's going to end up going to an hour anyway. Okay, so there's just two things I want to talk about today. First of all, I'm in the process of moving our setup for TR2 over to, the network topology for the actuators. I'm moving that over to Wi-Fi. So it's all powered over Wi-Fi using these little ESP modules. I want to talk about that, talk about my experience. It's not completely finished, but it's working. It seems like I'm not going to have any major issues with getting that set up. So I want to talk about a little bit how I've architected that. Maybe that helps you with your projects. I can talk about my experience with using other devices and other protocols or methods for communicating between your different nodes and your robot. And so hopefully that'll be helpful. And I also want to talk about old people. I was browsing Twitter last night and I found this company. I'm going to put them on blast, but whatever. They've raised $22 million, so I'm not, nobody should feel sorry for them. But they're getting ready to launch a robot for old people. And I have some thoughts on that. And we'll get into that and we can talk about maybe what they're doing right and what I think they're doing wrong. And who knows, maybe they'll make a video about us and about why we suck as well. So that would be great. We can get some back and forth going. We can start some Twitter flame wars. That would be cool. Maybe not. Okay, but we'll talk about ESPs first. So, ESP. So I've had this long journey of trying to figure out the best way to organize the network within the robot. Because when you're dealing with a robot that's got like 10 plus motors, 10 plus sensors, you've got a wide variety of different devices that are both doing things and reading data, and all of that has to be organized and sent back to some main program that's running on the computer that is just kind of managing all of this. There's just a lot going on, and I've had a very difficult time. I mean, really, I feel like now is the only time in my career. It's been a short career that I've been in robotics, but now it's really the only time where I feel like I've kind of figured that out. And I've had some good success with that. And it has been painful, just oddly painful, trying to figure out what seems to be just a very simple problem. You've got an actuator that has a motor and a sensor, and I just need to send commands and read data back. And it's just, I don't know why, but it's been very difficult. But I finally got a good solution. So where I started, whenever I started this company, like the most experience, I had been building the TR1 in my garage for a couple months before like actually forming the company. But prior to TR1, I really had just built really basic robots. Like I've mentioned this in the past. I built a wooden piece of plywood with a couple brackets and some motors on the side with some encoders. It had one Arduino Mega sitting in the center, and I could do some basic what's the term, kinematics, where I could basically tell it to move to certain coordinates. And that was really cool to finally figure that out. Like just the simple technology you could have. But then you build on a little bit on top of that. And okay, now we have 2 Arduinos and they need to talk to each other. If you have 2 Arduinos that need to talk to each other, well, that's really simple. You can do I2C. And I2C, there's good support for it on Arduino. And setting up that communication, setting up that bus is really simple. You just have one Arduino over here, another Arduino over here. There's 2 wires in between. It's probably a good idea. This is SCL, SDA. Probably not a bad idea to share 5-volt and ground between the 2 of them. But you really just need SCL and SDA. And you can be up and running, and you could be communicating between 2 Arduinos. And then you add another one. And then you plug into the SCL SDA bus, and then you have another one over here. And then, you've got this other sensor that's way on the far end of the arm. So we need to communicate with that. So we have these long wires. And it turns out I2C was designed to be used on printed circuit boards. So it wasn't designed to be robust to like a lot of electrical mechanical noise in the lines. So what can happen is if like one of these lines shorts out, or if there's a lot of noise and a bit gets flipped from 0 to 1, the entire bus can just crash. And there's different ways you can try to recover from that, but there was never, once I started getting to where like I had like 15 things plugged into this, and like it was, the distance of the wires on this bus were like, a meter, yeah, that's probably right. It ended up being pretty challenging to get this thing to do what I wanted it to do, because I needed to, like, if I had a sensor on the end of here it would accept commands for like the gripper, but it would also send the sensor or the state back to the main computer, because you would have this main computer over here that was plugged into I2C. I would need to send back a lot of data to this main computer, and I needed to send a ton of data back, like at a fairly high bandwidth. I mean, we're not talking like a bunch of data, but for I2C, it ended up being a lot. Like I needed to send back, let's see. I mean, you could do the position, which those go up to 1024. So that you have that would be 2 bytes, right? 255, yeah. So you need 2 bytes to store that number. So you would have to send that back over and over again. And it always crashed. We'd always have problems. You'd always have to go in and reset the bus by just turning the power off, turning back on. I also had this problem of, we're using these NVIDIA Jetson boards. You plug them into I2C, and I still don't know what's happened to this day. But we've had like 4 or 5 boards in the past that just completely fry from something funky going on in the I2C bus. And then when that I2C bus would fry, the HDMI would stop working on the board. So the board would still, like, you could still turn it on. It would connect to Wi-Fi if you had it configured prior to that, and you had it configured to automatically connect. So you could SSH into it, but then the HDMI would just stop working. So I2C ended up being a flop. But if I had more experience, I would have known, ahead of time that, I2C not really a good solution for anything not on a printed circuit board. So that was quite the experience trying to figure that out. We stuck with that, all the way through TR1. And then my early version of TR2 also had I2C, because it's like, what else am I going to use? You can use serial. But serial. Yeah, I did try serial. So serial communication, you would think, what do they call it? UART. You would think that would be perfect. But you have your main computer. You got your 2 lines that go over to your first Arduino, and then you're going to have 2 lines go over to your next Arduino, and then the Arduino after that, and you're going to just daisy chain the serial lines all the way to from this end all the way to that end. Well, the problem there is, well, you don't need 2 lines, you need 4 lines, because let's see, why do you need? Well, okay, you need 4 lines, not from there. That's right. You need 4 lines because basically this you have to connect 2 this way and 2 this way. UART is not set up as a bus. It's all one-to-one communication. So, the problem with that was ultimately, well, you would send, a byte of information here, and then it would just get dropped here. Something would happen here where the data didn't get through, so it wouldn't send the data on to the next thing. So, by daisy chaining it like that, you just increase the likelihood of something to go wrong, and then when it does go wrong, it can't recover by sending the data all through that way. And then also I was using Arduino Nanos in the actuators particularly, and the Arduino Nanos only have 1 hardware serial port. And you need to use hardware serial if you're going to send and receive data. If you're going to send and receive data reliably, you're going to need to use hardware, like a hardware serial port. And those Nanos only have 1. The Megas have 4, which is great, but they were too big to fit in the actuators. So I spent quite a while trying to figure out that, and again, not really knowing much about the technology, and not really knowing, I assumed you can just connect them all to these 2 lines, but come to find out that it doesn't work like that. So that didn't work. Then I thought, well, what about Bluetooth? Right? We could just do wireless. We can just do Bluetooth for each of these modules, or each of the actuators, and that can use the 1 hardware serial port that we have on the Nano, and that would be great, right? So we have all of these actuators. These boxes are Arduino Nanos, and then you would have the HC05 or whatever Bluetooth modules connected to each of these. I mean, all of these would have 12 volt and ground all running through them, so they're still wired together, but just not through communication. We have this main computer over here. I'd use a Arduino. I would use an Arduino Mega that's connected over USB serial to the NVIDIA Jetson. And then this would have the Bluetooth module connected in here. And then we would send out the Bluetooth commands to each one of these, and it would send data back and forth like that. And that would be perfect. But then, if you know anything about working with Bluetooth, you'll know that doesn't work, because Bluetooth is only one-to-one communication. I didn't know that. I thought, I should have known that just from, working with your phone and a headset. You can't use your phone and connect both to your headset and the speaker and another headset. It's only one device at a time. So it's all one-to-one. So what had to happen here is, okay, well, then I'll just add a new Bluetooth module for every actuator that we use. But there's 5 actuators in the arm. There's 2 actuators in the head. There's a Bluetooth. There would need to be a Bluetooth module in the gripper, so you can send and receive commands there. So what is that? It's 8 in total. And then the Arduino Mega only has 4 hardware serial ports. So you need to connect it up to another Mega over here, which also has these modules here. There's your 6, and then there's your 8. So then the wiring and the complexity of all the electronics in the base, this would be in the base of the robot, just was crazy. Like 3 megas, 8 Bluetooth modules, just so we could communicate with the actuators on top. This worked though. It worked great. Really great. You could send, because it was all one-to-one, you could send data back and forth so quickly. And I rarely had any issues communicating. Like I was able to get the speed back and forth between the actuator and the main computer. I was able to get that like as fast as I needed it. And the reason you want a high bandwidth and high frequency of communication between these two devices is because this main computer is making decisions based on what's going on in the actuators. So if you're getting data back only once every 1 second, did the actuator really get to the desired position? Or, there's different ways you could architect that with the assumption that that the communication's slow. But I didn't like that because I really wanted to know the exact state, the exact angle of the actuator for visualization. And, it just opens up the world of possibilities if you have that. If this computer is able to know, your main onboard computer running the operating system, if that's able to know exactly what's going on with the actuators. There's a lot more you can do with ROS integrations and things like that. So it worked, but it was expensive and it's complicated. To wire all this up, you have to go in, you have to configure each of these Bluetooth modules. You have to pair them together. So these two have to go in, you have to set, you have to get the, was it MAC address? I think it's the MAC address. Some address, right, of this device and pair it to this. You have to set this one as the slave device. This one's the master device. I would go in and set a password for each of them so that, not just anybody can log in and send commands to the actuators. You do have a security issue. I don't know how secure these devices are. So you had to configure that for each of them. Then these megas, I think, are like $5 a pop. These Bluetooth modules are like, I don't remember, but they're probably close to $5 a pop. It's just expensive and clunky. And it's not something like my goal with TR2 is that we can bring, any idiot off the street and say, hey, come in and build these robots, for our customers. Like that's how simple I want the design to be. That, we're not going to do that, by the way. We're not just bringing in any idiot. And in fact, I'm really proud of the people that we have on staff here. But, it's got to be that simple. And this wasn't that simple. So that's why I wasn't happy with it. It was time consuming to configure for each robot and clunky and expensive. So I was like, well, at least we've got a solution. But then, I'd known about ESP32s and using Wi-Fi and setting up networks. I've heard of other people having success with that. So just, in the past week or two, I've been able to start playing with that and getting that to work. It's been fairly challenging. There's not near as much support online for other people working with that as, like these HC05 modules. Those have been around forever. So there's just a lot more support. So there's just a lot of stuff trying to figure out how to get that to work. But eventually, so if we replace this actuator setup up here, let's assume now instead of Bluetooth modules, those are now ESP8266. I'll write that down. Let's see if you can see that. Yeah. Oops. 8266. So these are like these little Bluetooth or these little Wi-Fi modules that you can connect to your Arduino just over serial. And you can now have your Wi-Fi, you can have your Arduinos connected to Wi-Fi. And then with this base, we're able to take this entire setup, all of this right here, we can get rid of it. And instead of having all of that connected to the main computer, you can just have one ESP32 here that's running a web server, and it's connected over USB to the main computer. And then that gives you that one-to-many architecture that we were going for initially. So the electronics in the base, and actually I've posted this on Instagram. It was on a story, so it's probably gone by now. Follow us on Instagram. But I had shown, here's what the original setup in the base looked like. And there's just wires all over the place. And, I could have cleaned it up with, if I design a printed circuit board for it. And but it was still, either way, it was going to end up being a big mess. But I was able to swap all of those electronics out for just this one Bluetooth or this one Wi-Fi module, this ESP32 here. So this thing actually hosts its own Wi-Fi network. I mean, it literally costs like $7. And I'm sure, that's like on Amazon. So I'm sure you could probably get better deals elsewhere. And it hosts its own Wi-Fi network. And it hosts its own web server. So it's running an HTTP web server on this device as well. That offers many more benefits than just simplifying the architecture. This is just something I've stumbled upon. Because with the old setup, one problem was you have this complicated network. How do I see what the network state is? How do I see what the data is that's get passing around? This actuator is going here. How do I visualize that properly? If something happens, how do I dig in, figure out what went wrong, and fix that? As far as debugging goes, this makes that problem so simple because this is hosting a web server. Now, I have a couple routes where these modules, they'll connect to the Wi-Fi network. And once they're connected, they'll repeatedly send HTTP requests to the web server. And in that request, it'll update the state of the actuator. Here's the exact angle of this actuator. And that request, and then the response will actually be, here's what the latest command is that's been sent from this main computer. And those commands are getting sent back and forth over USB serial. And then that gets set as the state on the server. That just gets set as some variable in the server. And then anytime you send an HTTP request to each of these, the response is the latest command. Okay, so it's not it's not a constant stream. It's like for this actuator to get updated for the command, it has to send the request and the response has to get sent back. So the request is, we'll send a GET request to CMD A0. And this will be CMD A1, CMD A2. So actuator 0, actuator 1, actuator 2. And each one of those will respond with, in the body of the HTTP response, will be the command. And that command gets parsed by the actuator and then actually, turns the motor or, changes the mode, resets the state. I have a series of different commands you can send it. How this updates the state, and this was mostly, it's just the easiest way I could think of doing it, but you set a parameter on this route here. So let me rewrite that, see if you can see it. CMD A0, and then S equals 3.14, right? So S for state equals 3.14. When that request gets sent here, all that this server does is, okay, your A0, this is a command. I'm going to send back the command, and then I'm also going to parse this S parameter in your query as, okay, that's the state of the actuator. I'm going to set the variable here. So now next time I communicate with the main onboard computer, here's your here's your state of that particular actuator. So it seems, there's a lot going on here, but as far as the architecture of this goes, it's dead simple. It really is. It's really because you're only dealing with one module here and then one module for each of these actuators. And I've found that I've been able to get really what I need is where I can send, at a minimum, I need to be able to send one request every 300 milliseconds. So, if I can get 3 requests per second, that's pretty good. And that's good enough for, on my testing, that's good enough for what we need. I think we, with some fine tuning, we could probably crank that up more. But for now, that's good enough. So I've been able to get up to 300 milliseconds of requests. These are all able to request all at the same time, and I haven't had any issues with server load here, because the responses we're sending back, I mean, it's a really short and sweet response. Here's the command, basically. What's also cool, so I mentioned that problem of knowing what's going on in the network, being able to visualize or see what the network state is. This is now, so this has an index route. So here we've got CMD A0 as a route. If you just go to the index of the page, the server, the internal IP address is 192.168.4.1. If you go to this URL, if you're connected to that Wi-Fi network, then it pulls up an HTML page that has a table of all of here's the last command, here's the last time I received a command, here's the last state, and again for each of these actuators, and here's the last time I received a state. So if it's been a long time since I've received state, that means that there's some issue between the connection of these two. Probably something went wrong on the actuator's code, that it didn't handle a certain response properly, something crashed, so I need to go in and make sure that I'm handling those kinds of exceptions on the actuator side. It also, so that's awesome. I mean, that's a really big deal. I can also go in and send commands manually from that server. So what that means is I don't actually even need this main computer in order to get this system up and running and testing. Because you want to break down the connections as much as possible. And okay, let's focus on this. Let's make sure this works. Then we'll move on over here and make sure this thing works. Now we'll figure out how to connect the two and make sure the connections between the two of them work. If you try to build it all out at the same time, you're going to have problems. So you can actually, you don't need a main onboard computer. You can just visit that URL and send commands to each of these actuators manually. And you can test and make sure everything's working perfectly that way. So, but this is my setup, man. It is super, super simple. So in the base, we've literally got NVIDIA Jetson. We've got an ESP32. We've got the battery. And then I do have another Arduino and motor controller for the wheels in the base. So, the wheels in the base go round and round. I'm hilarious. Okay, so that has been my journey. Now it's still not done yet, and maybe I come across something that just makes it impossible for me to use this setup for some reason. The only thing I can see at this point is that I've only got 2 or 3. The most I've had set up are 3 actuators running at one time. Once I get to full 8 on there, am I going to have issues? Maybe. But I think the solution there could potentially be, okay, instead of ESP32, if that's not powerful enough to handle all of these requests, which it should be, I think it's able to handle up to like 16. But if it's not powerful enough, we can use a Raspberry Pi, for instance. You might say, why not just use the NVIDIA Jetson? And the reason you can't use the NVIDIA Jetson is because that also needs to connect to the internet. So it needs to connect to like your home network. The network for the actuators needs to be its own separate thing. You could potentially have a separate Wi-Fi device and configure that on the Linux operating system. And maybe that would be better. I don't know. But, that's essentially what we're doing by having, this ESP32 over here. So it's the same kind of thing. You would need something separate in order to host and maintain that network and server. So hopefully it works. It's been quite the journey, again, as I've explained, to try to get this set up. But now that this works, this is something that we can use for all robots in the future, and we can continue to improve it. And there's just, by having a server, we can have routes here that make it easier to run certain commands. And I've got a guy just bought a ARM recently. We've got a couple weeks. In fact, it's 4 to 8 weeks to fulfill orders. I'm going to be able to send this out with that ARM, and that's going to make it really easy, because the ARM doesn't come with the NVIDIA Jetson, but that's going to make it really easy to for them to get up and running. Where you could potentially use the ARM and just program that ESP32 to perform certain actions, and you wouldn't actually need a whole nother device. So anyway, that's just really cool. I'm really excited about that. But follow on Instagram. I should have updates pretty regularly with different development changes. I'm starting to post more on there. Okay, so I'm going to keep that at 32. I was going to put this company on blast about their old person robot. Well, we'll just save that for another time. I don't think there's anything wrong with people that want to build robots for old people. My point is, you don't know anything about that market. It's a bunch of people that are like 20 years old trying to build robots for old people. And you don't know anything about the lives of old people. We just got back from Kansas City. And my wife's grandma turned 85. And she's hilarious, first of all. And she's a delight to be around. And she's telling us stories from, she's 85, so she grew up, she would have been probably 10 years old, when World War II was going on. And, her life growing up was so much more different. Extremely so than, the life of someone my age. I mean, they grew up in the middle of a world war. It wasn't. Look, it was. You didn't know in 10 years if Germany was going to be running the whole planet. I mean, and she talked about the fact that everybody was pitching in to help with the war, and everybody was getting to work and doing what they can to share resources. And she said that she walked to school every day, and you probably don't know anything at all about what these people have been through in their life and the kinds of challenges they've overcome. And there's all, I just kind of get a sense, and the reason I kind of get fired up about it, I just kind of get the sense that they think, well, nobody says this, but I get the sense that they think, well, old people, they can pretty much use any help they can get. They would be easy. They'd be easy customers, right? They've got money. They'll pretty much give money for anything, and I just kind of get that sense, and nobody says that. And it's always, and the reason they're able to raise money is because it's with these good intentions. But yeah, it's just not a good market. Any market you join, just basic business fundamentals. Any company you're going to start, you need to understand that market better than anybody else. So you're going to serve this customer. You need to understand that customer really, really, really well. You need to understand the problem that they face, the problems they need help getting solved. You need to know how to solve those problems better than anybody else. And if you don't know that market, don't start a business in that market, or at least figure out what you're doing first. But yeah, they've raised $22 million for a robot for old people. Well, I mean, yeah, might as well show it real quick, and then we'll finish up. Hopefully this isn't too loud. But the robot's LEQ. Let's see.
And sent a new photo. Would you like to look at it?
Yes, please.
Oh, he's a gem.
Would you like to respond to Megan's post?
Sure.
Recording in 3, 2, 1.
So
LEQ reminds me to take my meds, arranges rides for me. She even reminds me of all my appointments.
Mary, don't forget bridge with the Golden Girls at 1 p.m. Would you like to practice?
Oh, I don't need to practice.
I didn't catch that. Do you want to play bridge or not?
Oh, fine. Let's play.
So, like, the whole idea is it's a robot that helps you keep track of your appointments. It helps you message people. And it keeps you from getting lonely. And I don't think that's going to be a powerful enough value proposition for anybody, much less old people. You wouldn't try to sell this to, Jibo, which was another robot. They tried to sell basically this kind of thing, and it flopped, right? So here's this company, and they're like, well, we'll do Jibo, but for old people. It's gonna flop, like old people, like they're already on Facebook. Your grandma's already on Facebook. She has a planner. She can keep track of her appointments. she's got those, okay. And if she's lonely, well, first of all, why don't you stop by for dinner more often, or get her a dog? That's gonna be better than this. This robot's, they're selling it for $14.99 for pre-order on their website. Yeah. More power to them, I guess, if they want to try to start this company. And, there's no harm in trying. But I just don't see it working. And it's not because the technology doesn't work. There's just, you're not solving a problem for anybody. You're not solving a specific problem for the elderly, for instance. You're it's because you don't know anything about what their life is like, and you don't know what they've been through in life. And if you could figure out something specific to help them with, then maybe you've got a business there. But this is just kind of like, a committee got around in a circle and they all just threw out good ideas, good sounding ideas for a product. And they went, we'll just kind of aggregate all of these ideas. We'll take, the three most common ideas and we'll go with it. But you've got to focus on something specific you can help people with. And that's true for any market. It's like whenever the iPhone app store came out first, and you see all these productivity apps and photo sharing apps, and these are the kinds of ideas that are produced by people that have no clear insight or vision. They're like, okay, I want to build an app. See, what ideas can I come up with? Like, that's the process, rather than I'm going through life, I encounter a problem, and I go, aha, I've got an idea for a solution that solves that problem better than anybody else. That's how you start a business. And they can figure it out. That's the other thing. I mean, this product is not going to help anybody, but they could take the feedback that they get from their users and turn it into something that's really specific and helpful. So, the company is not guaranteed to fail, but I would bet a lot of money on this product in its current incantation. Is that even a word? Going on a rabbit trail. Nobody's listening anymore. Incantation. Series of words says is a magic spell or charm. Yeah, I guess. Where do I pick up these words? Yeah, and its current incantation. It's not going to work. But, they could turn it into something that does, but it's not focused enough. And anyway, I think I've said my piece there. All right, so that's gonna finish her up today. Thanks for watching. I'm gonna stand up for this. Thanks for watching, and I will catch you guys next time. My name's Zach. Email me, zach@slaterobots.com. Our phone number and information is on our website at slaterobots.com. And be sure to subscribe. Click the notification bell. And you know what? Don't do that. I'm not going to be the guy that's going to tell you to subscribe and click the notification bell. Don't do that. Don't subscribe. I don't subscribe to anything anymore. I just go into the YouTube recommendations because, like, the subscription thing, like, who cares? YouTube does a good job of just recommending me videos. So don't subscribe. Just watch the video, and it'll show up in your notifications or your recommendations next time. So anyway, you guys take care. Be sure to comment or ask any questions, as I mentioned before. See you later.